different database providers. So what they are doing is, we are providing, this is a user application, he wants to access some data from a particular database. So what our application, this database virtualization is doing is that, so it's taking all the results of this thing, and it's providing a user interface where the user feels like it's a single database. It's something like, for example, if I'm an AT&T, I'm an AT&T owner, and I want to list the database, the phone numbers of different cities, and they have different databases. But I don't want to go into a particular city and I want to take it. I want a single query which shows all the results of different cities. This is what it is doing, because the different cities use different database structure or something like that. But using virtual database technology, what we are doing is, we are providing a common schema of all 4 databases, and user is being provided with a single area where he can access all the data. This is what the virtual database technology really means. And coming to the database virtualization technique, how exactly it works. We have homogeneous distributed database, like depending on the vendor, and we have depending on the model, like relational database, XML databases, object-oriented databases and all. So, and we depending on the location, for example, if you want to, depending on the location, in the sense, for example, here they use a different structure of database. In India, they use a different structure of database. When it comes to the internet, the person has to utilize all the data from different areas. So, depending upon the structure, either model or the different data model, the same data model, or different location, these all things are not to be judged when this data virtualization technique is used. Here we are providing an XML schema wherein all the data from this is gathered using XML schema, and it's transmitted to the user application. Yeah, this is coming to homogeneous distributed databases. There are some areas where we have homogeneous databases and heterogeneous databases. Homogeneous fall in the same way, like MySQL, MS SQL, PGSQL. They have almost a similar structure of arranging the data and organizing the data. So what exactly happens is, here is that this data is being exported into an XML export program, and this XML is transmitted to a virtual database. A user can see only this database, and this is the only single database, and he accesses the values from there. So this is what happens in the virtualization of the. I have a simple code which helps in mapping the databases. Like it has a XML version of the code wherein the data from the different databases is mapped to the virtual database. This is the XML code for that. And coming to the heterogeneous databases, like we have relational databases and XML databases and object-oriented databases. Coming to relational databases, what happens is that everything whichever goes on the internet is XML data. The data which is transmitted on the internet is bounded by XML file. So XML file is which is transmitted to the internet. So in case of RDB, we need to convert the relational database into the XML schema. And coming to the XML, we need not convert because it's already in the XML format. And coming to the object-oriented, there is also an issue with that, and we have to convert it into XML schema. So to convert this, we have proposed in this research paper which I have chosen. This is a 2010 IEEE paper. In this, what they have done is they have provided a database query which can access data from different tables, and it can map into a virtual database. This is a virtual database query. We are developing a virtual database query language which maps the XML schema of the different databases to the virtualized database. So the mapping takes place in the query processing language. There is a new language introduced called virtual database query language, which maps the common schema of the different databases. It maps the schemas of the different databases and provides as a single output. And coming to the conclusion, we are able to convert the RDB schema into XML schema. I've just showed two databases has been converted to a single virtualized database, and there are researches going on, like research is going on to implement this XML DB to make it as a common XML, to make XML schema to be common. XML schema to be common for virtualized database. So for example, I have three database tables of different structurally ordered, and it is being converted to a virtual database. And this virtual database should have the common schema of these three. This is the research which is going on. So, location transparency. User doesn't need to know that he is getting information from this table and this table. This provides a very good feature that, and it helps the user to get. I mean, it avoids the workload on different databases. And these are the differences. Any
questions?
Yes. What exactly is the virtualization? The database, is it just virtual schemas or virtual tables? What is it exactly?
It's a virtual schema actually. What happens is that if, for example, I want to access four databases of differently organized structures. I want to take data from different tables, but they are organized in different way, and they will not support my application. It's in the distributed application, so distributed database. So when distributed computing, all the databases should be properly defined, like they should be uniquely defined. But over the internet, what happens is that I want to collect data from different databases and they are differently structured. So in this scenario, what happens is that we are creating a coupling layer kind of thing. I mean schema. The layer is what schema, which is a virtual database, which maps to the common schema of these three.
There was another question, last question. You mentioned that the XML schema was stored in the virtualization layer.
Yeah.
If you know the answer, do you know what the DTD is stored in? Is that also in the virtual layer?
Yeah, it's also the.
It's defined as XML now instead of your normal. Is the so you're not storing the data in the virtualization? You're storing what the relations are.
Yeah, what the relations
and
are.
You're having
which table it's coming from.
And you're having to map the relationships.
Yeah, mapping to the relations.
It's not automatically done. You say I want this data, but and here it's coming from here, and over here it's coming from these different things. So you're mapping that.
Yeah, we are mapping on a virtual layer, but user doesn't know that it's coming from this layer and this layer, this layer. He sees only a single database.
So when it pulls multiple result sets from multiple databases,
yeah,
it pulls it across to the virtualization layer. And then if you're comparing the data between the three, it didn't have to go through and do any more logic that it couldn't do at the database levels at the virtualized level on the data.
Yeah, at the virtualization data, you don't have these workloads and all. Because, for example, searching a particular data in three different data tables is it's a workload. So putting a query onto the virtual
right,
database.
but let's say you return the data from database 1.
Yeah.
We'll call it a relational database. You return data from the third, we'll call it object database. I don't want all the results union together. I want the results compared together and then getting a subset of the union between
Yeah,
the two.
you can perform all the SQL queries on the virtualized database.
Okay.
Whatever you can perform all the SQL queries in it. It's the same as the database, but it's providing data from different databases. It's mapping from the different databases.
I got the same question. If you're saying that the DTD is in the virtualization layer, then how does the other database know what the format is if they don't have a DTD at their site? How does that work?
Yeah, it's, for example, for transmitting a data to the internet or anywhere, we need XML schema for every database, right? So when for a particular database, we have XML schema. It's one XML schema. We are mapping that XML schema with this virtualized database schema, and we are accessing the virtualized database schema. I hope you got it. Am I too fast?
Well, because I know that if it doesn't exist on the client side, then it won't be able to communicate properly with the virtualization because there's no validation in place.
If it's not available, it is definitely it's not going to happen. For example, if you are trying to access a table, it is not available. That's what it is.
No, not the table talking about the XML schema. DTD basically determines if the document is valid or not. Because when you extract the information from the database, the converted into XML, then the XML has to be validated with the DTD document. If it's not on the client side, then how is it talking if it's just in the virtualization side? It should be on the client side and in the virtualization.
You actually don't have to use the DTD. You can.
Well, I know you don't have to, but it just
Well,
makes
you're getting the client just gets the results set back. It doesn't care.
But what if he's putting information into the database?
No putting in the database. It's
Well,
only
the
for dynamic database.
virtualization layer would should convert that to instructions into the database.
Any other questions? Yeah, thank you.